Mr. McGrew recorded videos like outside in the dark and it was just fading. It was scary.
There we go. They can sort of see my face there.
So we do need to find his button.
So looking at page 263, number 27. So the main concern was you didn't know how to graph it, or you didn't know what the graph would look like. I don't know what the graph looks like either. I mean, it's a parabola, but other than that, I don't really know. But I think I can contend that I can get by without knowing what the graph looks like. Because if I'm coming from the left, then my first height will be the height at 2 from the left. I tried to color code, but the lighting makes it a little tricky. From the left, that would be that height. If I'm coming from the right, it would be that height would be the first one. So I don't know if doing them at the same time is helpful or confusing, but the next height, if I'm coming from the left, would be g of 2.5. And then g of 3, 1/2 g of 3.5. I do need to be careful when I get to the end to make sure I don't do too many of these. But I'm 6 rectangles, so I should have 6 rectangles. So 1/2 g of 4 and 1/2 g of 4.5. Are you okay that we didn't make it to g of 5? Does that make sense? Because coming from the left, whatever they look like, we don't get to use the height at 5. Coming from the right, we won't use the height at 2. We'll start at 2.5, and then the next one will be 1/2 g of 3, 1/2 g of 3.5, 1/2 g of 4, 1/2 g of 4.5, 1/2 g of 5. So on that one, I do get to all the way to the right because I'm using the rightmost heights. I don't know if that's helpful to put both pictures on one graph, but
all clear, all clear, all clear. May I have your attention, please? The situation requiring us to use our lockdown.
He said good morning and the person outside thought he was good morning.
okay. So are we? Do I need to finish that out, or are you good from there?
Good.
I mean, there's some more tedious stuff to do, like plugging in 2, 2.53, all of those, but you've got it set up. That's not a safe stop, but are you okay if I stop there? Ask it that way. So I've done the problem, and I still don't really know what the graph looks like. All right, 33 was the other one we were going to look at. This one, they give us the picture. Use upper and lower sums to approximate the area of the region using the given number of subintervals of equal width. We'll hit a few today that don't use equal width, which is kind of annoying, but it's still just adding rectangles. All right, square root of x. And just from 0 to 1. With 4 subintervals. The picture in the book might be tricky because it's showing the lower and the upper rectangles, and that's kind of tricky to make sense of. So let's just do the uppers first, and then we'll do the lowers. So the upper area. So for the upper area for this particular problem, is that going to be from the right or from the left? If I want to upper sum. From the right. So I want the upper area, that'll be these heights. So the width of each one is 1/4 this time. And again, if you're getting comfortable with these and you want to factor the 1/4 out front and put parentheses and just know that the 1/4 goes to everything, that's fine. I usually, I don't know, somewhere in here I start doing that, but it's still only day 2 of this, so I'm going to leave it as 1/4 times f of 1/4, 1/2, 3/4, and 1 plus 1/4 f of 1/2 plus 1/4 f of 3/4 plus 1/4 f of 1. And then double check, that's 1, 2, 3, 4 rectangles. I'm supposed to have 4 rectangles, so I feel good about that as an answer. We didn't finish the last one, so let's finish this one at least to a safe stop. So f of 1/4 means the function at 1/4, and the function is just take a square root. So square root all of those values. And obviously some of those will simplify easily and some won't, but it doesn't really matter because that's a safe stop. So there's our upper sum. Our lower sum, that means we're coming from the left-hand side. So our first height is at 0, f of 0, which is 0, so that first rectangle is a 0 height rectangle. 1/4 f of 1/4, 1/4 f of 1/2, 1/4 f of 3/4, but not 1/4 f of 1 because we only want 1, 2, 3, 4 rectangles. And that f of 3/4 is the last height that we use. So 1/4 square root of 0, 1/4 square root of 1/4, 1/4 square root of 1/2, 1/4 square root of 3/4. And again, some of those will simplify. You're welcome to simplify them. But if you leave it unsimplified, it's easy to see the pattern. So a lot of times the safe stop, it prevents you from making a mistake, but it's also helpful to see the pattern is far more visible before you start plugging things in the calculator. All right, so that was 2 good ones because one was a left and right and one was a upper and lower. And so again, upper and lower, it depends on the problem as to whether you use the right or the left, increasing, decreasing. 29. Here's another one where if we don't know what the graph looks like, we could still set it up, and we could definitely use a safe stop here. Because you can leave cosine of 0 and cosine of pi over 2 as answers, as safe stop places. All right, use the left and right endpoints. 2 approximations. Okay, so again with the left and right stuff. Let's see, cosine of 0 is 1. Cosine of pi over 2 is 0. Yeah, that's right. So there's our area. 4 rectangles. Oh, this is going to be, so half of pi over 2 would be pi over 4, and half of that would be pi over 8. So we're counting by pi over 8s. 1 over 8, 2 over 8, 3 over 8, and 4 over 8. And that sets up our intervals here. So if we come from the left, area is approximately equal to, what's the width of each interval? How wide is each rectangle going to be? Pi over 2 is the entire width, so pi over 8. Are you okay if I factor pi over 8 out of everybody so I don't have to write it 4 times? Okay, so I'll do that this time. Since that's the width for all of them, I'm just kind of peeking ahead. I'm going to go ahead and factor it out. Again, If you like that because it makes you write less, great. If you don't want to do that because you want to write length times width plus length times width plus length times width, that's okay too. So from the left, f of 0 plus f of pi over 8 plus f of pi over 4 plus f of 3 pi over 8. And that's not quite a safe stop because we need to plug those in. So cosine of 0 plus cosine of pi over 8 cosine pi over 4 plus cosine 3 pi over 8. And that is a safe stop because that's calculator ready. So you're like, well, I don't know what cosine of pi over 4 is, much less cosine of pi over 8. You don't have to. If you want a decimal, then type it all in, but you're perfectly okay to leave it like that. If we want to come from the right, that means we're using the heights on the right side of the rectangles. So I'll start at the right on this one. Again, you don't have to do this. You could start at the left as long as you use the right hand height. But for some people, starting all the way at the right makes more sense. All the widths are pi over 8. F of pi over 2 plus f of 3 pi over 8 plus f of pi over 4 plus f of pi over 8. And we don't use f of 0 because that would be a rectangle out of our region. Or because we've got 4 rectangles, we don't need any more. And so then it's just plugging those into the function and not really even evaluating them, just leaving them like that. Again, if you don't like the going backwards like I just did, you'd have the same answer. You would just have those terms in a different order, and that would be fine.